Comparing frequentism and Bayesian statistics. In the heart of the university's bustling cafeteria, amidst the clatter of dishes and the murmur of many conversations, sat Alex, a student with an insatiable curiosity for the mysteries of statistics, and Professor Paul, known for his ability to infuse humor into the most complex topics. As they enjoyed their lunch, the topic of discussion turned to a comparison between frequentist and Bayesian statistics. Professor Paul, Alex began, their fork pausing mid-air. I've been trying to wrap my head around the difference between frequentist and Bayesian statistics. Could you explain it to me, perhaps with some of the humor you're famous for? Ah, the eternal debate, Professor Paul chuckled, leaning back in his chair. Imagine you're at a carnival, and there's a game where you have to guess the number of jelly beans in a jar to win a prize. A frequentist would focus on the long-run frequency of events. They'd say, given the size of the jar and the size of the beans, I calculate there's a 95% chance the number of beans is between 300 and 400. Alex nodded, intrigued. Now, Paul continued, a Bayesian enters the scene and says, I think there are about 350 beans, but I could be convinced otherwise if you provide me with more information. Maybe I know the carnival owner likes to fill the jar to the brim, or perhaps I've seen similar games before. The Bayesian updates their belief based on prior knowledge and new evidence. So, it's like the Bayesian is more flexible? Alex ventured. Exactly. Paul exclaimed. Bayesians incorporate prior beliefs with new data to update their understanding. Now, imagine you're trying to decide if you should bring an umbrella to campus. A frequentist would look at historical weather data and say, it's rained 30% of the days this month, so there's a 30% chance of rain today. A Bayesian, on the other hand, might say, yes, but the sky is overcast, and the humidity is high, which increases the probability of rain today, given my previous experience. Alex chuckled, the examples making the concepts clearer. Here's where it gets fun, Paul said, his eyes twinkling. Let's say you're baking cookies for a bake sale. A frequentist would strictly follow the recipe, saying the recipe has been tested and, under these conditions, works 95% of the time. A Bayesian, though, tastes the dough and thinks, based on my past baking experiences, a pinch more salt could make these even better, and adjusts the recipe accordingly. So, the Bayesian approach is more personal, more subjective? Alex asked. In a way, yes. Bayesians use prior knowledge and continuously update their beliefs as more data becomes available. It's a bit like life, isn't it? We learn, we adjust, and we improve, Paul concluded with a smile. As they finished their lunch, Alex felt enlightened. The world of statistics, with its frequentist precision and Bayesian adaptability, seemed less daunting and more fascinating. And, thanks to Professor Paul's humorous examples, the concepts would stick with them long after the cafeteria's clamor had faded. Thanks, Professor Paul, Alex said, gathering their things. I'll never look at jelly beans, umbrellas, or cookie dough the same way again. Remember, Alex, Paul called out as they parted ways, statistics is not just numbers, it's about understanding the world. And a good dose of humor can make even the most complex theories digestible. With a new appreciation for both statistics and humor, Alex stepped out into the world, ready to apply their newfound knowledge to the mysteries that awaited.